Hello everyone, my name is Gal-Oren and I'm the head of the Scientific Computing Lab in the Nuclear Research Center Negev and a last year computer science doctoral student at Ben-Gurion University of the Negev. Our poster highlights some initial results from the evaluation of the novel storage system called InfiniBox by Infinidat. Our results show that InfiniBox is a cost-effective and easy-to-deploy solution for the HPC masses, which looks for a powerful yet effortless storage solution for the small to mid-range supercomputers. So while the demand for compute power constantly rises, the cost of powerful compute machines decreases. In such a worldview, a lot of research institutions which found numerous workstations as a sufficient compute power in the past move forward to maintain their own small-scale in-house supercomputer. Indeed, while the top notch of these supercomputers consist of millions of cores, most of the daily used clusters are made out of a much modest amount of compute nodes. On the other hand, while most of the supercomputers were built to maintain massively parallel large-scale applications, an increased amount of modern cluster CPU hours is utilized for inversely parallel applications. These applications ends up in massive amount of independent, relatively small files. Furthermore, both reads from and write to these files is often sequential. The traditional storage solutions consist of two separate groups. One family of solution is the massively distributed file systems, such as Lustre and GPFS. The throughput is high, and they are highly scalable. However, deployment of such system might be expensive and frustrating. The other type of storage solutions is the NAS storage, which offers relatively limited network capacity while offering a plug-and-play installation. Between these two kinds of solutions, there is a recognizable gap. So we looked for a system which will be some kind of an easy-to-deploy NAS and still be able to produce high throughput. Our search led us to InfiniBox by Infinidat and to a fruitful collaboration to find the path to utilize this state-of-the-art system for supercomputers while enhancing the performances. InfiniBox provides a parallel multi-tiered storage system with up to 12 fast internet interfaces with up to 25 gigabit per second each, as for current internet technology. InfiniBox includes a group of algorithms called neural cache that find patterns in data access and predict future I/O requests, which are then staged in cache for faster responses. By doing so, InfiniBox adjusts itself to any I/O pattern. InfiniBox neural cache handles data placement in real time, enabling over 80 to 95% of reads from DRAM, and the majority of the rest to come from flash. This results in low latency while keeping the majority of data on hard disks, which result in an optimal cost structure for large datasets. We used the well-known IO 500 benchmark test to evaluate the InfiniBox storage solution in the new supercomputing configuration. All of our results shown in the poster. I would like to highlight two charts. The first chart is the IO easy test, where each client sequentially writes to and reads from its own file. Here we can see that InfiniBox outperforms Lustre throughput, both in reads and write. Note that the tested Lustre machine was connected using RDMA 56 gigabits per second InfiniBand connection and maintained its own client software, while InfiniBox was connected using simple 25 gigabit per second Ethernet connection and accessed using the common NFS client. In the empty test easy test, each client creates, stat, and deletes its own files. The lack of single metadata server, which is the case in Lustre, enabled InfiniBox to gain advantage over Lustre and to provide a competitive amount of IOPS. On both tests, the performance achieved by a single 25 gigabit per second network interface of InfiniBox was similar to that was achieved by a standard unscalable RAID storage machine, although the network speed of the latter was almost twice. Using InfiniBox with multiple network interfaces increased the performances even more dramatically. Well, that's it for now. I was Gal-Oren. Thank you very much.